Welcome aboard, where aviation concepts become simple. From instruments to aerodynamics, we make exam prep clear and cockpit learning faster. This is StudyKwik Aviation.
Welcome to StudyKwik. Today we'll define the purpose of the vertical speed indicator, VSI, and see how it works. The VSI helps pilots monitor climb and descent rates accurately. The VSI indicates the rate of climb or descent by sensing changes in static pressure. When the aircraft is in level flight, the VSI shows 0. Rates are usually displayed in feet per minute, although sometimes meters per second are used. This helps pilots maintain safe vertical speeds during flight. The VSI can be thought of as an airtight case containing a pressure-sensing capsule and a metering unit. Static air feeds both, allowing the instrument to sense altitude changes. Inside the metering unit is a restrictive choke that slows pressure changes inside the instrument case. This creates a pressure differential during climbs or descents. The pressure differential drives the pointer on the VSI dial, showing vertical speed. When the aircraft returns to level flight, pressures equalize and the VSI returns to 0. The VSI also self-compensates for changes in altitude and air temperature. Static pressure passes through a capillary tube and choke orifice, maintaining accurate readings. This ensures a consistent rate of climb or descent indication, regardless of altitude or temperature. The VSI remains reliable for safe flight level in varying conditions. The VSI is susceptible to errors: instrument, position, maneuver-induced, and time lag. These are normal and expected in a functioning VSI. Instrument error arises from friction, wear, and minor manufacturing imperfections. It is generally small, but can increase at higher altitudes in sensitive instruments. Position error, also called pressure error, occurs due to turbulent airflow around the static source. This can cause false climb or descent readings, especially during speed changes. Maneuver-induced error comes from short-term pressure fluctuations during pitch changes. Flight level deployment or landing gear operation can temporarily affect VSI readings. Time lag occurs because the VSI takes a few seconds to establish the pressure differential. This is most noticeable after prolonged climbs or descents at high rates. Blockages in the static source will cause the VSI to freeze at the altitude of the blockage. During a climb, it will underread, and during a descent, it will overread. Leaks outside the pressure hull produce minor pressure fluctuations, affecting VSI slightly. Leaks inside the cabin render the VSI unreliable, as it reads cabin pressure instead of ambient pressure. VSI displays come in two main types: linear and logarithmic. Linear scales are good for high climb descent rates, while logarithmic scales are sensitive at low vertical speeds. The instantaneous VSI, IVSI, solves the time lag problem by responding immediately to altitude changes. It uses a dashpot, a small piston, and spring system in the static line. During a climb, the dashpot piston moves instantly, creating a pressure differential. This allows the IVSI to indicate the true rate of climb immediately. During a descent, the piston moves in the opposite direction, giving an instantaneous descent reading. However, turbulence or steep banked turns can cause false readings. A simple way to calculate rate of descent is using the 1 to 60 rule. For a glide slope of 3 degrees, the height loss equals 3 units for every 60 units of horizontal distance. If the aircraft travels 6,000 feet, 1 nautical mile on a 3-degree glide slope, height loss equals 300 feet. At 60 knots ground speed, this takes 1 minute, so VSI equals 300 feet per minute. Quick formula: rate of descent, feet per minute, equals 5 times ground speed in knots for a 3-degree glide slope. This provides a fast and practical method for pilots. Summary: the VSI measures vertical speed using static pressure changes. Errors include instrument, position, maneuver-induced, and time lag. all expected in normal operation. The IVSI corrects time lag using a dashpot for instantaneous readings. Rate of descent can be estimated using the 1 to 60 rule or simple formula. Thank you for watching StudyKwik. Like, share, comment, and subscribe for more aviation lessons.